What made the geocentric model so mathematically difficult? Imagine trying to draw a map of the night sky with just a simple circle. Now, imagine that map had to match every star and planet's movement perfectly. That was the challenge with the geocentric model. Back then, astronomers believed Earth was at the center of everything. All planets, the sun, and stars moved around Earth in perfect circles. But the problem was, planets didn't move in simple, smooth paths. Sometimes they seemed to go backward in the sky, which was confusing. This backward motion is called retrograde motion. To explain this, astronomers used complicated ideas. They thought planets moved on small circles called epicycles, which in turn moved along larger circles called deferents. These circles helped match what they saw in the sky, but they made the math much more complicated. Instead of simple paths, they had to calculate many small circles moving on larger ones. Sometimes, the center of the deferent was not exactly in line with Earth. They called these eccentric circles. This meant the circle was offset, making the calculations even trickier. It was like trying to draw a perfect circle but shifting the middle point slightly off-center. Then came the idea of the equant point. It was an imaginary spot away from Earth, from which the planet's motion seemed to be uniform. This idea helped predict planetary positions better but broke the idea that all motion should be perfectly circular and centered on Earth. It was a clever fix, but it made the math even more complex. All these adjustments meant astronomers had to add more and more epicycles and eccentric circles to match their observations. The system became a tangled web of circles within circles. Despite all this effort, the model still couldn't predict planetary positions with high accuracy. It was like trying to hit a moving target with a complicated set of rules. This complexity was one of the main reasons scientists started to look for a simpler explanation. When the heliocentric model, with the sun at the center, was proposed, it used fewer circles and epicycles. It was easier to understand and predict planetary motions. Throughout history, the geocentric model shows how humans used the best tools they had to understand the universe. But the math was so difficult because it had to account for all the strange motions of planets with a system that kept growing more complex. Moving to the heliocentric model was a big step forward because it simplified the math and gave us a clearer picture of how the cosmos really works.